Hi, so for our experiment, we chose to take the pink fluffy cowboy hat and figure out which USN surface has the most friction by sliding the hat on 3 different surfaces and figuring out which one has the highest coefficient of kinetic friction.
The materials we used for our experiment were the pink cowboy hat, a meter stick, and a phone timer.
So this is our force diagram. We have the force of gravity, which we calculated here using the weight of the hat, and then also the normal force, which was the other force acting in the vertical direction, which was the same as the force of gravity.
And there were no other forces acting upon our hat.
Besides friction.
Besides friction,
which is what we're finding.
Haha! So, yeah. Here's what our experiment looked like.
Mm-hmm.
Okay.
Ready? Okay, got it.
As you can see in the videos, we slid the hat across the 3 surfaces and measured both the time it took for the hat to stop moving and also the distance from where it started to where it ended. And once we had those values, we were able to calculate the initial velocity of the hat.
I will do in one moment. So this is an example of how we found the initial velocity. This is for surface 1. We took our equation, plugged in our numbers. This was the distance that it took to stop. This was the time it took to stop. Final velocity was 0 because duh. And then we're solving for the initial velocity, which was that number. Then we did that for all of the other 2 surfaces and all of the trials.
So once we had the initial velocity, we were able to get to all the way to the acceleration. We did this by using equation number 4 from the 6 equations. And then plugging in all of those values, doing that math, comes out to give you an acceleration value. We did these equations 3 times per surface for each of our trials, and then we calculated an average acceleration for each surface.
So after we had the acceleration for each surface, we then plugged into our wonderful equation F net equals ma, and we did it for each surface to figure out what F net was. Because once you have F net can equal Ff because there were no other unbalanced surfaces acting upon our object. Therefore, our F net is the coefficient of friction. Now we're back with our F net equation. So we plugged in our average acceleration for this is all for surface 1. Plugged in our average acceleration for surface 1, the weight of our hat, and then once we did that, then our F net, we know that F net equals force of friction, as we just explained. So our force of friction for surface 1 is 0.69. But we're not done, because now we have a force of friction, but we need to figure out the kinetic friction. So we took our equation, force of friction equals kinetic friction times normal force. So this number equals kinetic friction times the weight times normal force. And then after doing some wonderful math, we got that our kinetic friction for surface number 1 is 0.68. Then we completed this for all of the other surfaces, and we'll be back with those numbers.
So from all of that data and analysis, we come to an amazing conclusion. The surface with the least amount of friction is the bench, which is 0.31. In the middle is surface 2, the tile floor, which was 0.64. And the most friction is the carpet with 0.68. This was slightly surprising to us because we predicted that the tile floor would have the least friction, but it's actually in the middle. We were correct, though, that the carpet would have the most friction.
We had some errors in our trials, such as people walking into our path or the hat kind of flying off the ground, which we corrected by running new trials that provided the most accurate data available. This project taught us a lot about how to plan an experiment over multiple days, work together, and create a procedure that takes possible issues into account.
So, in conclusion, if you were ever wondering, which USN surface has the most friction, the answer is the carpet in the library, out of the 3 surfaces that we tried.